Hi, welcome back to my class in Analytic Geometry. Today we will solve the last set of problems on distance and midpoint. And in the next lesson we will start with linear equation and the graph of linear equation in 1 and 2 variables. Consider the following example. Find the point 0y that is equidistant from 4, -9 and 0, -2. We are given that this point with coordinate 0y has the same distance from the point with coordinates 4, -9 and from the point with coordinates 0, -2. So what we will do is we will get the distance of this point 0y from the point 4, -9, and we will also find the distance of this point 0y from this point 02, and we will equate the two distances because they are equal, because this point 0y is equidistant from these 2 points, and from the resulting equation we will solve for y. First, we represent this point 0y as the point P. Let P be the point with coordinates 0y. And we let this point with coordinates 4, -9 as the point A. Let A be equal to 4, -9. And the third point, we denote this as the point B. So B is the point with coordinate 0, -2. By the given condition in the problem, the distance of this point 0y from point 4, -9 denoted by PA is equal to the distance of this point P from the point with coordinates 0, -2, or B. And these two distances are equal because the point P with coordinates 0y is equidistant from point A with coordinates 4, -9, and from point B with coordinates 0, -2. By distance formula, the distance between the points P and A is the root, the positive root or the principal root of the sum of the square of the difference of the abscissas of points P and A, denoted by square of x2 minus x1 plus the square of the difference of the ordinates of points P and A, denoted by y2 minus y1. And I want to remove the radical sign from the right hand side of this equation, so I will take the square of both sides. The square of the distance between P and A, the points P and A, is equal to, you raise both sides to the power 2, and from algebra, the square of the root of this expression or radicand is equal to this radicand. So the right hand side simplifies to x2 minus x1 square plus y2 minus y1 square. Now we substitute the coordinates points P and A. We take this as the point with coordinates x1, y1. And we take the coordinates of A as the point with coordinates x2, y2. Thus, the right hand side is equal to the square of x2. x2 is 4. Minus x1, abscissa of the first point P, 0. To the power 2 plus y2 is the ordinate of the second point A, negative 9. Minus the ordinate of the first point P, y. To the power 2. And we simplify the right hand side. The square of the distance between points P and A is equal to 4 minus 0 is 4 to the power 2. Again, 4 minus 0 is 4 raised to 2 is 16. Now to simplify this, I will factor out negative from each term, and we get negative of negative 9 divided by negative is positive 9. Negative y divided by negative is positive y. And we take the square. We simplify the right hand side. We have 16 by property of exponent, the square of negative times 9 plus y is equal to the square of negative times the square of 9 plus y. And 9 plus y can be written as y plus 9. 9 plus y is equal to y plus 9 because addition is commutative. So the second term is equal to the square of negative is positive times the square of y plus 9. To get the square of y plus 9, we applied one of the special product rules, the square of a sum, or the square of a binomial. So the square of the distance between the points P and A equals 16 plus the square of 9 plus y. From algebra, the square of a sum from algebra is equal to the square of the first term, the square of A, plus twice the product of the two terms A and B, plus the square of the second term B, or B squared. This is a special product rule from algebra, and we apply this to get the square of y plus 9. So the square of y plus 9 equals the square of y. You compare this special product rule with this. Your A is y and your B is 9. And the square of y plus 9 equals the square of the first term, y squared, plus 2 times the product of these two terms, y and 9. 2 times y times 9. And 2 times 9 is 18 times y, 18y. Plus the square of the second term. And the square of 9 is 81. And we simplify further the right hand side. We get the square of the distance between the points P and A is y squared. I will write the terms at the right in decreasing powers of y. So we start with y squared plus 18y plus 16 plus 81 is 97. This is the square of the distance between the points P and A. Next, we will get the square of the distance between the points P and B. If you take the square of if you get the square of both sides, the square of the distance between points P and A, and the square of the distance between points P and B, you get the equation, the square of the distance between P and A is equal to the square of the distance between the points P and B. And we took the square of both sides so that we can eliminate the radical sign. Now we have the square of the distance between the points P and A. It's given by y squared plus 18y plus 97. We will now get the square of the distance between the points P and B, and then we will equate the two. And from the resulting equation, we will solve for y. We now get the square of the distance between the points P and B. And by distance formula, the distance between the points P and B is given by the principal root of the sum of the square of the difference between the abscissas of these points P and B and the square of the difference between the ordinates of these points P and B. Since we want the square of the distance between the points P and B, we take the square of the left side and the square of the right hand side. Thus, the square of the distance between points P and B is equal to this expression. By property of radical, the square of the root of this expression is equal to this expression, the radical. Now we take x1 and y1 as the coordinates of P. Is your x1, y1. And we take the coordinates x2 and y2 as the coordinates of the point P. 0, is 0 is your x2, negative 2 is your y2. Thus, the square of the distance between the points P and B equals x2 is 0 minus x1 is 0 to the power 2 plus y2 is negative 2 minus y1, ordinate of the first point y, to the power 2. And we simplify the right hand side of this equation. We have the square of the distance between points P and B The first term will go because it's 0. 0 minus 0 is 0. 0 raised to 2 is 0. We only simplify the second term. I will factor out negative from negative 2 and negative y. Negative 2 divided by negative is positive 2. Negative y divided by negative is positive y to the power 2. And we apply the property of exponent. If you have a product raised to the same exponent, it's equal to the square of the first factor, negative 1 raised to 2, times the square of the second factor, 2 plus y. So the square of negative of 2 plus y equals the square of negative 1 is positive times the square of 2 plus y, which I will write as y plus 2 is squared. 2 plus y again is equal to y plus 2 by commutative property of addition. And this is the square of the distance between the points P and B. Now we write the equation by equating the square of the distance between P and A and the square of the distance between points P and B. Earlier we obtained the square of the distance between the points P and A, and it's equal to y squared plus 18y plus 97. And this is equal to the square of the distance between the points P and B. The square of the distance between the points P and B is given by the square of y plus 2. Again, we apply the special product rule for the square of a sum or for the square of a binomial. And the special product rule says the square of a sum is equal to the square of the first term. The first term is y, and the square is y squared. Since we have a sum here, the second term is positive. And the second term is 2 times the product of these two terms. 2 times y times 2. But 2 times 2 is 4. Multiplied by y is 4y. And the last term is for the square of a sum or difference. The last term is always positive. And it's equal to the square of this second term in this binomial. The square of 2 is 4. Hence, we substitute the square of the distance between points P and B here. We write y squared plus 4y plus 4. And we solve for y from this equation. You can see that the right hand side has y squared and the left hand side has y squared. So if you subtract y squared from both sides, y squared will cancel out. And to solve for y, we transpose all the terms with y in one side of the equation and all the constant terms to the other side of the equation. At the left-hand side, we have 18y. Positive 4y transposed to the left, we get negative minus 4y. At the right-hand side, we have 4. And positive 97, you transpose it to the right-hand side and take the opposite sign, and we get negative 97. 18, these are like terms or similar terms with y as the common literal coefficient. 18y minus 4y, 18 minus 4 is 14y. And 4 minus 97 is negative 93. Negative 93. And to solve for y, we divide both sides of the last equation by 14. And 14 will cancel out from the left-hand side. And this gives us the value of y equals negative 93 over 14. And the point that whose coordinates we want, the point 0y is the point 0 and y is negative 93 over 14. Negative 93 over 14. The distance of this point from point A and from point B are equal. And the distance is given by this or by this. We check the distance of P from A, the square of the distance from between the points P and A, and this is our point P, is given by y squared plus 18y plus 97, where y is negative 93 over 14. We write negative 93 over 14 to the power 2 plus 18 times negative 93 over 14 plus 97. And we will compute this using calculator. And then after you have computed the right hand side, you get the root, the principal root. And the answer here should be equal to the distance between the points P and B. The distance between the points P and B, the square of the distance between the points P and B, is given by y squared plus 4y plus 4. Where the value of y is negative 93 over 14. We have y squared negative 93 over 14 to the power 2 plus 4 multiplied by y, this is the square of the distance between P and B, plus 4 multiplied by y, negative 93 over 14 plus 4. And we will compute this again using calculator. And after we computed the value of the right hand side, we take the root for the distance between the points P and B. We will use a calculator to find these values. Using a calculator, the value of the square of negative 93 over 14 plus 18 times negative 93 over 14 plus 97 is 21.56. You can try to calculate the value of this and you should get 21.56. And 21.56 is the square of the distance between the points P and A. And to find the distance between the points P and A, we get the principal root or the positive root of 21.56, and it gives us a value of 4.64. units. This is the distance between the points P and A, where point P is the point with unknown ordinate y, or the P is the point with coordinates 0, negative 93 over 14, where negative 93 over 14 is your y. And A is the point with the given coordinates 4, negative 9. Similarly, you can calculate the value of this, the square of negative 93 over 14 plus 4 times negative 93 over 14 plus 4. And you should get 21.56. 21.56 is the square of the distance between the points P and B. And to get the distance between the points P and B, we extract the root of 21.56 and it gives us 4.64. 4.64 units is the distance between the points P and B, where P is the point 0y, and we found y. So P is the point with coordinates 0, negative 93 over 14. And point B is the point with the given coordinates 0, negative 2. Hence, we have checked that the point P with coordinates 0y, or coordinates 0, negative 93 over 14, has the same distance from point A and from point B. That is, point P is equidistant from A and from B. The distance of P from A is 4.64 units. The distance of P from B is also 4.64 units. And we plot these points in the Cartesian plane, which consists of two axes. The horizontal axis is the x-axis. The vertical axis is the y-axis. At the intersection of the two axes is the point 0. We start with point A, has coordinates 4 and negative 9. You start from the origin and you count 4 units to the right, to the positive x-axis. And from there you count 9 units downward. I will use a 1 unit intervals for this graph. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 units downward and 4 units to the right. For point A, count 4 units from the origin, 1, 2, 3, 4. And from this point, you count 9 units downward. And this is the first given point, A. The second given point with known coordinates is the point B with coordinates 0, negative 2. From 0, you count 2 units to the left, because again, B has coordinates 0, 2. The abscissa is 2, so you start from the origin. And the ordinate of B is negative 2. That means from the origin, you count 2 units downward. 1, 2, this is negative 2. And this is the point B. Now we plot point A. Point A has coordinates 0, negative 93 over 14. Negative 93 over 14, we have to approximate the value of 93 over 14 to 2 decimal places. So we can plot the point P with coordinates 0, negative 93 over 14. We have calculated the value of 93 over 14. And you can check this value using your own calculator. Negative 93 over 14 to 2 decimal places is negative 6.64. Now we can plot the point P with coordinates 0y or coordinate 0, negative 6.64. Abscissa is 0. Hence, from the origin, we count 6.64 units downward. And we have used a 1 unit intervals for the vertical axis. This is 1, 2, 3, 4, 5, 6. Approximately 6 point. This is the point P on the vertical axis. And the distance of point P from point A we have shown is 4.64 units. This is 4.64 units. We have also shown that the distance of P from point B is also 4.64 units. The point P is equidistant from A with coordinates 4, negative 9, and from B with coordinates 0, negative 2. Or the distance of P from A and from B are equal. And that distance is equal to 4.64 units. We now take another example that involve an isosceles, a right isosceles triangle with the given 3 vertices. And in this problem, we will show that the triangle with the given vertices is a right isosceles triangle. And you know from your geometry before that a right isosceles triangle is a right triangle, which means that one of its angles is a right angle whose measure is 90 degrees. And an isosceles triangle has 2 legs that are congruent, and these 2 legs are opposite the congruent angles of a right isosceles triangle. Consider the following problem for our example 2. Show that the triangle with 0, 1, 2, 3, and 2, negative 1 as vertices is a right isosceles triangle. The 3 vertices of the triangle are given, and these vertices are the points 0, 1, 2, 3, and 2, negative 1. And we represent these vertices with capital letters. We let the first vertex A be the point 0, 1. The second point 2, 3 be the vertex B of the triangle. And the third point given with coordinates 2, negative 1 be the third vertex C. And we plot these points in the Cartesian plane with y in the vertical axis and x in the horizontal axis and 0 at the intersection of the 2 axes. The point A has I use a 1 unit intervals in the vertical and horizontal axis. The first vertex has coordinates 0, 1. The abscissa is 0 and the ordinate is 1. So the point A is a point on the vertical axis. This is point A. Point A is 1 unit from the horizontal axis. The second point or second vertex of the triangle has coordinates 2, 3. You count from the origin, you count 2 units to the right to the positive x-axis, and from there you count 3 units upward. From the origin we count 2 units, 1, 2 to the right, and from 2 we count 3 units upward, 1, 2, 3. And this is the point. The point B with coordinates 2, 3. And the last vertex of the triangle is at the point 2, negative 1, which we denote by C, 2, negative 1. From the origin, you count 2 units to the positive x-axis, 1, 2, and 1 unit downward. This is the third vertex, C. And we connect these vertices to construct the triangle. That's the triangle with vertices at point 0, that's point A, 2, 3, that's point B, and 2, negative 1, that's point C. We have to show that if this is a right isosceles triangle, 2 of its sides are congruent. That means the lengths of these 2 sides of this triangle are equal. And secondly, we have to show that the lengths of the sides of this triangle satisfy the Pythagorean theorem, because only a right triangle will satisfy the relationship among the 3 sides of a right triangle given by the Pythagorean theorem. First, we show that 2 of these 3 sides are congruent, and the length of each side will be given by the distance between the 2 vertices of this triangle. We start with this side through the line segment, through the points, through the vertices A and B, and we get the distance between A and B. The distance between the vertices A and B by distance formula is the principal root of the square of the difference of the abscissas between A and B plus the square of the difference between the ordinates of A and B. And we take A with coordinates x1, y1 as the point 0, 1. Hence 0 is your x1 and y1 is 1. And we take B with coordinates 2, 3 as the point with coordinates x2, y2. Hence your x2 is 2 and your y2 is 3. AB is now equal to the principal root. X2 is 2 minus x1 is 0 to the power 2 plus your y2 ordinate of B is 3 minus the ordinate of A1. And we simplify the right hand side, this side through the vertices AB as a length equal to the principal root. 2 minus 0 is 2 And the square of 2 is 4. Plus 3 minus 1 is 2. And the square of 2 is 4. Or this gives us the root of 8. Hence this side of the triangle with through the vertices A and B has a length of square root of 8. The principal root of 8. Now we take the distance, the length of this side, the side through the vertices A and C. And to find the length of this side, we get the distance between point A and point C. By distance formula, the distance between the vertices A and C is equal to the principal root of the square of the difference between the abscissas of A and C plus the square of the difference between the ordinates of A and C. y2 minus y1. We take A as the point x1, y1. Hence, x1 is 0, y1 is 1. And we take C with coordinates x2, y2. Thus, x2 is 2. And y2 is negative 1. We write AC is now equal to the principal root of x2 is 2 minus x1, 0. 2 square plus y2 is the ordinate of C, negative 1. Minus the ordinate of A1 to the power 2. To simplify the right side, we have AC. This is the length of the side of the triangle through the vertices A and C. We have the principal root of 2 minus 0 is 2. Raised to the power 2 is 4. Plus negative 1 minus 1 is negative 2 is square. And the square of negative is positive times the square of 2 is 4. So negative 1 minus 1 is negative 2 to the power 2 is 4. And we get 4 plus 4 equals the root of 8. Hence, the length of the side of the triangle through the vertices A and C is the root of 8. Thus, this triangle has two congruent sides. The side through the vertices A and B, and the side through the vertices A and C. These two sides of this triangle are congruent. They have the same length, equal to the root of 8. Now we will verify the Pythagorean theorem. And because if this is a right isosceles triangle, it must satisfy the relationship among the three sides of a right triangle given by the Pythagorean theorem. And we take the hypotenuse as this third side through the vertices B and C. We have now the distance between AB, square root of 8, and the distance between AC, square root of 8. Now we will find the distance between the vertices B and C, and we will verify the Pythagorean theorem. We now compute the distance between the vertices B and C by distance formula. The distance between the vertices B and C is the positive root or the principal root of the square of the difference of the abscissas of points B and C plus the square of the difference of the ordinates of the points B and C. We take the point B with coordinates 2, 3 as the point with coordinates x1, y1. Hence, our x1 is 2, our y1 is 3. And we take the point C with coordinates 2, negative 1 as the point with coordinates x2, y2. Thus, our x2 is 2 and our y2 is negative 1. We write BC is equal to the principal root of x2 is 2 minus x1 is 2 to the power 2 plus y2 is negative 1 minus y1 is 3 to the power 2. And we simplified the right hand side. We have BC, the distance between B and C is equal to the principal root of 2 minus 2 is 0 and 0 raised to 2 is 0. So the first term will go because it's 0. The second term, negative 1 minus 3 is negative 4 to the power 2. The square of negative 4 is 16, or by property of exponent, the square of negative 4 equals the square of negative 1 times the square of 4. But the square of negative 1 is positive 1 times the square of 4, which is 16. We get 16. And this is the distance between the vertices B and C. The side of the triangle has a length equal to the square root of 16. And earlier we find that the distance between AB is the root of 8. We also found earlier that the distance between A and C is also equal to the root of 8. Now we check if the sides of this triangle will satisfy the Pythagorean theorem. And by Pythagorean theorem, the Pythagorean theorem says that the square of the hypotenuse is equal to the sum of the squares of the two other sides or the legs of a right triangle. And you can see in a right triangle, you know that the longest side of a right triangle is the hypotenuse. Hence, between square root of 8 and square root of 16, square root of 16 is the larger length. Hence, this side of this triangle through the vertices B and C must be the hypotenuse. If this is a right triangle, we take this side BC as the hypotenuse. By Pythagorean theorem, the square of the hypotenuse In this triangle, we take BC as the hypotenuse because it has the, the largest length. The longest length is square root of 16. The square of the hypotenuse is equal to the sum of the squares of the two other sides. The square of this side through vertices AB, and the square of this side through the vertices AC. This is the equation that we want to verify. We start with the square of BC, the square of the side through the vertices B and C. The distance between the vertices B and C is equal to the root of 16. The root of 16, and you take the square of it by property of radical from algebra. The square of the root of 16 is equal to 16. This is the left-hand side of this equation obtained by Pythagorean theorem. Now we find the value of the right-hand side of this equation obtained by Pythagorean theorem. We find the square of the distance between A and B plus the square of the distance between A and C. The square of the distance between A and B is given by the root of 8. And you take the square of it plus the distance between the vertices A and C we found is equal to the root of 8. And we get the square of this. Again, by property of radical from algebra, the square of the root of 8 is equal to 8. Plus the square of the root of 8 is 8. And 8 plus 8 equals 16. Therefore, we have verified that the triangle, this triangle, with the given vertices satisfy the Pythagorean theorem. Therefore, we can conclude that this must be a right triangle with the right angle at vertex A. Because the side opposite vertex A, this the side through the vertices BC, has the longest length. And we have taken that as the hypotenuse, for which we have verified that if BC is the hypotenuse, the Pythagorean theorem is satisfied. Therefore, we conclude that triangle ABC, the triangle ABC with vertices A at this point 0, 1, B at this point 2, 3, and with vertex at this point 2, negative 1 is a right isosceles triangle. It's a right isosceles triangle because we have shown that two of its sides are congruent. The first property, the distance between AB is equal to the distance between AC. That is, two of the three sides of this triangle are congruent. And letter B, we have shown that this triangle is a right triangle because it satisfies the Pythagorean theorem. That is, the square of BC is equal to the sum of the squares of the two other sides, AB and AC. In the next lesson, we will start with the graph of linear equation in one and two variables, and we will express the equation of a line in different forms. If you have question about the examples today, the problems on distance and midpoint today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan. Thank you.